Can you hear me? Yes, it seems to work. Yeah, welcome to the jungle. And this is more, it's not really about the latest and greatest, and I don't talk about ChatGPT or AI or anything else. This is really because we figured out that a lot of people use Java and have no idea about what's out there, right? That's the main idea. So I try to bring some light into the jungle. So my name is Gerrit Grunwald. I'm working for Azul. We do JVMs. And I'm also a JUG leader, Java champion, and other stuff not so important for this talk. If you would like to have the slides, I just uploaded them maybe half an hour ago to SlideShare. You can find them there. Otherwise, just ping me on Twitter, and then I will send it to you. It's hansolo_. That's my Twitter handle. OK, let's talk about OpenJDK. Who's using OpenJDK here? You know you're all wrong. OpenJDK is the source code, right? Because if I ask if you use Linux, people raise their hands, and I ask who's using Ubuntu, who's using Red Hat Linux. You use a distribution which creates a build of OpenJDK, right? Just to get that right, because if you ask people, what do you use? I use OpenJDK. Ah, of course you use, of course, what else? Well, this is a free and open source implementation of the Java Platform Standard Edition, shortly Java SE. That's OpenJDK. And it has a website that you can find here, openjdk.org. And because it's open source, there is the source code available. And in the meantime, it's available here at GitHub. So if you would like to see what's going on, you can check out github.com/openjdk/JDK. Well, because it's open source means there's more than one contributor. And you see there's lots of contributors here. And I have put all the individuals is just one point, many individuals, because there are many. And this is a good thing, because you see there are lots of big companies here on this list. And that should give you some confidence that Java is still there and will be there, because if these companies invest in Java and OpenJDK, then you can make sure it will last for another 10 years, maybe longer. So it means it's not a one-man show, which is a good sign. And it comes with a roadmap. Probably many of you know that. This is the old release cadence, and if you ever worked before JDK 6, then you know it took forever for next versions to come out. So you heard something, and then, oh, there was an announcement, and then 4 years later you get the release. And then that changed, right? So it was 4.5 years, then it was 3 years to JDK 8, and that means you have to wait multiple years before you can test a new JDK version in production, for example, or even in development. Well, with the new release cadence, it looks like this, and you see the pink ones, that's the new so-called LTS releases, which means it's a long-term support versions. We will come to that later. And they started with 3 years between the LTS, and now it's 2 years, which makes sense. And we are shortly before 21 here. And with this, you can imagine, you can now test a new JDK every 6 months. And that means new features that you can already test. Doesn't mean you have to implement it in production, but at least you can test it, and you can be prepared for the next LTS and make sure everything works. Right, so because I have to come to this point later again, we have to shortly look into the JVM, which is the heart of OpenJDK. And it has 3 subsections here. You see there's a class loader system, then there's a JVM memory, and there's the execution engine. And of course, these are not these stupid blocks, but they contain a lot of different things like class loaders, linking, initialization, and then in JVM memory, we have lots of different things like method area, heap, the stack, the PC register, some native method stack, and the execution engine comes with the interpreter, the C1, C2 compiler, garbage collector, and profiler, and also it has a native method interface JNI and native method library. So this is in principle how the structure of the JVM looks like, and it's an abstract computing machine. Okay, so these are all the basics. Probably most of you knew that. It's not that important, but sometimes it's good to know. This is split into JDK and JRE, which means Java Development Kit and Java Runtime Environment. And The JRE contains the Java Virtual Machine, the JVM, and the class libraries. That means this is the stuff you need to run your application. And then there's the JDK, which is a superset of the JRE. So it means it contains the JRE, plus it has the Java C compiler, Java doc, and the debugger. So this is the stuff you need for development, right? Why I say that is I saw people using JDKs in production. You don't have to, it's bigger. And in terms of space in cloud environments, this is money, right? So if possible, and if you are below JDK 9, you should use a JRE in production and a JDK in development. Why do I say below JDK 9? Because if you're above JDK 8, that means 9 and above, we have the module system and we have JLink. And who's using JLink here in production? And that's what I expected. It's interesting. So you can shape your JVM, right? Your JDK. If you use JLink, it means you need to dig into it. It takes a little bit of time, but it can give you a smaller JDK, which is tailored to your needs. You should take a look at that. So my recommendation is if you use, who's using JDK 11? I'm talking about production. JDK 11? 17. Wow. 8? And now below 8, someone? Yeah, don't be shy. Yeah, I know. Some companies just can't change. That's the reality. Okay, that leads me to this main topic here, distributions. And you will be surprised how many distributions we have, because we have builds of OpenJDK, and I do a separation here. And that's the list. That's the list I found. There are more. These are the ones that at least come with some packages. Packages, it's something like a tar, a DMG, a zip file, whatever. There are others, they just come with 10 packages or 5. That doesn't really count. So this is stuff that you can find on the web, and there are some really interesting ones. Who knows Tencent Kona? Dragonwell from Alibaba? Probably some people heard about that. And this is, or Bisheng, Huawei, right? It's big companies. Tencent is big, and they use that. And nobody knows, in the Western world, nobody heard of that. So, but they have quite some JDKs that you can download there. And you see I have some dead ones, like Adopt OpenJDK. Who's using Adopt OpenJDK still here? One? I'm not talking about Adoptium Tamarin. I'm talking about Adopt OpenJDK. Okay. This is dead. It died with 1602. Afterwards, there was a new project called Adoptium, and they have a different distribution, which is called Tamarin, right? They did a smart move. So if you download the latest version from adoptopenjdk.org, you get Tamarin. But this is a different distribution. And OJDK build, this is the free build from the Red Hat version from the community, but they stopped it. So they have some builds. I think the latest one was 16 or 17 something, and then they stopped. So this is also dead. Then we see stuff like Samaru and Samaru certified. This is IBM. This is in principle, to be correctly, this is not OpenJDK, because IBM has, with OpenJ9, they have their own JDK, but still, it's compatible. Yeah, so I put it in the list. It's 20 distributions, right? And then we have builds of GraalVM. Who's using GraalVM here? Someone in production? Native image? No, it's not that widely used. So, but still, there are already different builds of GraalVM available. So you will find Gluon, which is for mobile, and GraalVM Community Enterprise, Community Edition, Enterprise Edition, and then there is Liberica Native Image Kit, and there is Mandrel, which is from Red Hat, the build of the GraalVM source code. Okay, these are all the different distributions. The question is which one to choose, right? There are some obvious ones. So if you're on AWS, you probably use Corrado. If you're on Azure, you probably use Microsoft's build of OpenJDK. If you're on Google Cloud, you can use whatever you like. But the question is there any difference? And what is the difference, if there is one? So differences are, I just tried to put a list where we have some points that we can use to make a decision. So first of all, the support term, I will come to that. Updates, compliance, cost. Performance features, I don't know why they come up with two at once, but okay. Performance and features. So these are the points we will look into for most of the distributions, and then you hopefully have an idea. Oh, and there are also some alternatives to the standard. We will come to that too. So first of all, support term. It sounds strange. Who heard of that? Yeah, this is this one. STS, short-term support version, and LTS, long-term support version. You probably heard about LTS releases, and all the others are STS releases. And this is all the different JDKs that we have from JDK 9 on over the years. And then you see all the white ones are the STS ones, and the pink ones are the LTS ones. In principle, the same that we saw before. And the long-term support, you see here the dates, that's the reason why, right? So you can get support for these versions for a long time, where for the others, for the STS ones, you only get 6 months, right? So keep that in mind. If you use, who's using an STS release like 16, 15, 14 in production, someone? Or 18 or 19? That's a good sign. So you shouldn't use that in production because you only get 6 months of support. If then, for example, if you're 19, 20 comes out and they found a problem in 19, but you can't change because it's a lot of work to do. You have that trouble in your JVM and there might be a security issue, for example, which is fixed in 20, but they don't backport it. If I say they, I mean Oracle, right? So that means in production, you should better stay on LTS releases. Oh, and the other thing is not every distribution has LTS and STS releases. You will find some, they only have LTS. I think it's something like Dragonwell. They don't offer 19 and 18. They offer 11, 17, and they will offer 21, right? So all the LTS ones. Recommendation, STS and LTS in development doesn't matter. But in production, stay to the LTS ones. Do yourself a favor. Okay, then we have updates. And updates, we have also different ones. There's CPU updates, critical patch updates. Does someone ever heard of that? Honestly. Because there's also PSU updates, patch set updates. Did someone heard about that? Okay, the reason is that you probably only know these ones. Who has a subscription for Java SE? Doesn't matter where, Oracle, Azure, whatever. Someone? Don't be shy, I can't believe it. So the reason is CPU updates, they only contain fixes for vulnerabilities and for critical issues. Where you have PSU updates, they contain the CPU, but they also have fixes for non-critical issues and they introduce new features. And that means new features could have new issues, right? So what usually happens is, first of all, we get them 4 times a year, and it starts in, that's the stuff that you know, 1701, for example, in January. You see on top it's the PSU, and it contains the CPU, and in the bottom you see only the CPU. And if we go to the next one in April, then the fixes from the 1701 PSU get into the CPU 1702. The reason for that is because it only contains fixes for critical issues and vulnerabilities, no new features. The new features go into the PSU. If you use a CPU, you're always 1 step behind, but you're on the safe side. If you run mission critical stuff, you should really think about that. So, and then this goes on, July, October. So that means in the end, if you stay to CPU, you also get all the features, but always a little bit later than with the PSU. So, patch set updates are available from everyone. So the stuff that you download, if you use Xamarin or Corrado, they all give you PSU releases, including new features and non-critical issue fixes. The only companies that offer CPU releases is Azure, Belsoft, and Oracle. And the reason why you don't know that, because you have to pay for that. That's one thing you have to pay for. This is only if you like. At least for Azure and Belsoft, you don't have to pay for it. Right? You can just use the same thing without, and then you don't get the CPU. But if you would like to have the CPU updates, you really have to pay for it. That's how it is. And that's maybe the reason, but because you can't really freely download them. But if people here remember JDK 8 from Oracle, they had this 80251, 80252. That was the CPU and PSU. So in the past, they offered that for free. Now you have to pay. Okay, recommendation, like I said, in development, use CPU, PSU, whatever. But in production, if you run mission-critical stuff, you should better use a CPU release, if possible. Compliance, this is also something people sometimes don't care about, but it makes sense. First of all, there's the so-called TCK license. Who knows TCK? Heard about it. Okay, a few people. Technology Compatibility Kit. It's licensed by Oracle. And what it is, it's now we have some really nice words here. So first of all, again, two at once. I don't know why. So originally developed by Sun Microsystems, then now it's intellectual property licensed by Oracle. And they have more than 120,000 individual tests just for JDK 11. And they really test Java itself. It's not something like application tests. They test the APIs. They test also, for example, do you have an audio system connected? Do you have a printer connected? And all these kind of things. Everything that belongs to Java is tested in these TCK tests. And every binary that is produced has to pass the test. If I create, for example, I create one for Windows as MSI, this has to pass the test. If I create from the same source, I have to create a zip file, has to pass the test. You have to make sure, and you have to guarantee that somehow, that you run these tests. And that really takes a long time to run all these tests. Then there is the so-called JCK, which is part of the TCK, and this is the actual tests. Because some companies just mention, oh, we are JCK compliant. Then you know, okay, if they're JCK compliant, that means they also compliant to the TCK because JCK is part of the TCK. It's all a little bit confusing. I'm totally with you. So this JCK contains tests that it tests features like, again, what is that? I don't know. It's really strange. I always, when I click, I have 2 points at once. You have different implementation on different platforms that you might know, of course. You have different hardware you have to test. And then you have difficult things to port beyond, between different platforms, for example. It can be related to hardware implementations or also operating system behavior. All these things are in this JCK. So you can get access to that. And for that, and again, it's available at no charge. And then there's this nice thing. It must meet the terms of the OCTLA, which is the OpenJDK Community TCK License Agreement. Great. That's easy. So it's a lot of paperwork, but you could, for example, go to Oracle and apply for that, and you will probably get it. And then you must sign the OCA, the Oracle Contributor Agreement. Again, more paperwork to do. And then you get it. And then you can build your own JDK, which is TCK compliant. Is someone building his own JDK here? OpenJDK build? You should give it a try. It doesn't really take long. If you have a fast machine, it's okay. But running these tests, believe me, we have just a whole server farm just running for all these tests. It's so many things. You need all the hardware, all the operating systems, all these things. You have to test everything. And for example, these are the JDK distributions that are compliant, JDK 8 to the TCK. Remember, we had 20 in the beginning. This is not 20 anymore. That's less. And for example, you see here Dragonwell, right? And why I mentioned that is if you take a look and you take a look at the website, they just say, oh, we are TCK compliant. You say, oh, that's cool. So I'm safe. I download it. I download JDK 11. Well, for JDK 9 and above, they don't have TCK. And you can look that up. Why I'm picky about that is, for example, with Dragonwell, they built in a feature in the JDK 11 branch, and that breaks the TCK test. That means if you run your application on that JDK distribution, you might run into exactly this problem that crashed the TCK test. And then you have a problem, right? How will you fix that? That's the reason why TCK compliance is a good thing. You saw that most of these JDK distributions already are TCK compliant. But if you use something very special, then just be aware that it could break at some point. Then there's another one, which is called Aquavit. I don't know if it's not the Aquavit that you can drink. It's the Adoptium Quality Assurance Vitality and Speed Test Suite. Wow, another great name. This is by Eclipse. It came with the Adoptium project. And the story behind it is that Adopt OpenJDK was not TCK compliant. Right? The reason for that was that it had OpenJDK in the name, and that is trademarked by Oracle, and Oracle said, no, we won't allow you to do the test. That is one of the reasons why we now have Xamarin and Adoptium and not Adopt OpenJDK anymore. So this is the story behind it. And when they came up with that, they said, you know what? We also would like to have our own test suite, which is Aquavit. And Aquavit ensures that all additional qualities are present that make it suitable for production use. It has lots of tests. So you can think about that the TCK and with the JCK inside is more, this is the JVM itself, where the Aquavit test makes sure that it is performant, it runs on all these applications. So it's a different kind of test suite. And yeah, it's designed to test real-world utilization patterns with your JDK. So the Aquavit tests, these are the only distributions that pass this test. And you can download them on the Adoptium Marketplace page. There is a page where you can download these versions. And you see Dragonwell passes this one because it's an application test. It's not really on JVM level. It's different. But these are the ones that you can download that are compliant. JDK 11 and above, because Adoptium just came with JDK 17, I think. All right, recommendation, again, what you use in development, it's not really that important, but in production, make sure at least it's TCK compliant. If it's also Aquavit compliant, okay, that's fine, but the TCK thing is really important. There's another thing with the TCK, because we saw the contributors to the JDK. It's lots of companies, and they have patents. And if you have a JDK that is compliant to the TCK, you are allowed to use that patents. If you use a JDK that's not compliant, then for example, HP that have some patents, they can say, oh, you know what? Your JDK is not TCK compliant, so you're not allowed to use this in this patent. Right? So this could happen theoretically, but yeah, that's the legal part of it. Then we have something like cost, which is a different thing. We can do some differentiation. We have free versions, and we are also used to use free software, right? Which sometimes sucks, but yeah, that's the way it is. All these distributions you can use for free in production, right? So it's a lot, nearly all of them. Of course, there are some where you have to pay for. You have to pay for stuff like Azure Platform Prime, which is our premium JVM. And then there's IBM Xamarin Certified. And you pay for that because the certified, IBM has to pay for the TCK test. Because Oracle said, you know what, Xamarin with OpenJ9 is not really OpenJDK. If you would like to have the TCK, you have to pay. So that's the reason why we have IBM Xamarin Certified, where you have to pay for. Then we have GraalVM Enterprise. And I also put in the braces, it's based on the number of vCores mainly. And then we have Oracle JDK. So there was an interesting change in the beginning of the year. I'm not sure if you're aware of that, but Oracle made a smart move when it comes to calculation of the cost for an Oracle Java SE subscription. So that means if you now subscribe to the Java SE subscription by Oracle, you're not paying for vCores, but you have to pay for the number of employees in your company. That's easy, right? Easy to calculate for them, but very expensive for you. Means if you have a company with 10,000 employees, and one said, oh yes, I agree to the license agreement of Oracle, you pay for 10,000. And that's not a joke. And if you have a third party that delivers stuff to you, they also count. And if you have an existing Java SE subscription with Oracle, you better check, because that doesn't mean that you can stick to the old thing, to the vCore stuff. They have some really specific things that if something changes, you suddenly apply for the new rule, and then they stay and ring on your door and say, hello, you have 1,000 employees, you have to pay for 1,000. So you better check. If you have an Oracle JDK subscription, then be aware. And this is also true for Graal Enterprise. Graal VM Enterprise is the same. Okay, another thing we have differences is performance. There's, first of all, baseline performance. You saw it, most of them are builds of OpenJDK source code, and that means that's more or less all the same speed. Doesn't matter. You can compare them. Good luck. You will find, oh, this one was 2 milliseconds faster than that one. Ooh. It's because it's the same source code, it's not really that big of a difference here, right? So that means it's more or less the same performance. It doesn't really matter which one you use. Then you have high-performance applications. They need different JVMs. And then we have to take a look at the JVM, why they are different. So I already showed you these 3 blocks in the JVM. And the execution engine is the one we would like to take a closer look. Because it has this JIT compiler and garbage collector area, and you can replace that, right? That's what we did, for example. That means if we have Azure Platform Prime, which is our own premium JVM, we just wrote our own compiler and exchanged the one in the OpenJDK with our own compiler. And also the garbage collector. We built our own garbage collector and put it in there. The garbage collector is in principle the thing that is now ZGC, but we did that already 10 years ago. And the compiler produces faster code and is based on LLVM. So that makes it faster code, and we can do 0 garbage collection pauses with up to 20 terabytes of heap. And that's the thing you have to pay for, of course, because we wrote all that stuff. Then there is Oracle Graal VM Enterprise, which is also quite fast, but only the Enterprise edition. They put in a different compiler and a lot of optimizations. So this is also, if you really run high-performance stuff, then these are the 2 you should take into account. There is, for example, Samaru from IBM. It is not really faster. It's a bit faster than the OpenJDK standard builds, but it has a faster startup and a lower memory footprint. So that's the reason why I didn't really put it here. It's not that much faster than Oracle OpenJDK. So, and a faster JVM can help reduce cost, of course, right? If you can do the same stuff with less cores, then you pay for less cores, okay? And that means if you have a faster compiler, of course you can save money in the cloud. So that's something you have to keep in mind. And I don't know if you have played around with the Graal VM native image, for example, with Spring Boot native or Quarkus native. Just do yourself a favor, run the stuff on the JIT, on the JVM, and run it with a native image. And you just compare the throughput, and you will see that the Graal VM stuff is slower. It could be slower by 50%, and that's also no joke. There's something on Beldung.com. They made a comparison, and they compared Quarkus versus Spring Boot, JIT versus native. And you can see, it was really interesting to see that the Graal VM native image, yes, it has a fast startup, but the performance drops because they don't have all the optimizations that is in Graal VM Enterprise. And if Oracle talks about Graal VM Enterprise and the speed, they talk about the Enterprise edition, not the Community edition, just to keep that in mind. Okay, features. This is because it's like with Linux. I ask you, do you use Linux? People raise their hand, and I say, oh, do you use Red Hat and Ubuntu and Debian and Arc and whatever? And people will agree that these are not the same. Even if it's Linux, these are different flavors. The same is true for distributions. So in principle, they are the same, but vendors add more features to the JDK. First of all, there's JavaFX. Yeah. Who's using JavaFX? Someone? Okay, I'm using it sometimes. There's only 2 distributions that come with JavaFX bundled, which is Azul Zulu and Bells of Liberica. So that's it. So you can't really use more. Then there's Bells of Liberica Native Image Kit. That's the Graal VM version. It also comes with JavaFX. So if you would like to create a native desktop app using JavaFX, you can use this one, which is great. ARM32, someone using ARM32 stuff here. This is mainly for embedded, but because it's not the biggest market for, or let's say the biggest visible market, but in the automotive industry, this is big. And again, there's only Azul Zulu and Bells of Liberica that supports ARM32 ports here. This is stuff you can make a difference. And then we have alternatives. I have to take a look at my watch. We still have some minutes left. Alternatives, and now I get to these different features, right? Like we have Amazon Corretto. Who's using Corretto here? Who's using Snapstart, by the way? Someone? Okay, cool. Yeah, Corretto comes with Snapstart, which is faster startup, especially for Lambdas. They use the Crack API, and Firecracker is the whole thing to start up Lambdas faster. So this is the only thing that they have in difference. Then there's Alibaba Dragonwell. I mentioned that already. And they have the standard and extended edition, which is fine. And they have JWarm experimental faster startup, which is interesting because there's something we invented at Azul, which is called Ready Now. And when we started, we just tried to work on the C2 compiler in the JVM. And then at one point we figured out, we need more stuff in the JVM, so we just put that into our premium JVM in Prime, where we have our own compiler. And then we stopped working on that OpenJDK port, and Dragonwell took that one. And this is the reason why they don't have TCK compliance now. Yeah, in JDK 11. So, and I heard it could work, but yeah, they are not really tests. And my problem is I'm not that good in Chinese. So then they have something called Elastic Heap, where the GC can return memory back to the operating system. And they have WISP2, a stackful symmetric coroutine at JVM level. So this is all stuff they built in for Alibaba Cloud. But I already checked, so I think nobody's really using Alibaba Dragonwell here. But in China, it's big. Tencent Kona, I already mentioned that one. I guess nobody's using that, but they are specialized on ARM. And they have some really nice features. They have, for example, Kona fibers. And they are in JDK 8 and 11. And it's the same as Loom. And they have comparisons with Loom. And it's faster than Loom. And they already have that. It's not the same. So I don't know what they did. But they have tests on their website. You can check it. And they show that it's faster than Loom. And this is already JDK 8 and 11. So and the reason for that is they are on ARM. They would really like to make use of this Loom stuff. Yeah. So the virtual threads. And for that reason, they built it in. And they also created ZGC for ARM. They also have that. So you see they are really specialized on ARM. That means if you are in the embedded space, automotive or whatever, then this is the JDK you should really use because they have lots of features for ARM-based hardware. There's Oracle GraalVM. I mentioned that already. We have a community and enterprise edition. We have Polyglot VM, and we have a GraalVM JIT compiler, which is in principle a replacement for C2, but they decided to write that in Java. Then they created a native image out of it and used this one in the JVM, which makes sense. It's easier to support later on. And then they have the Graal IoT compiler, which creates the native images, right? Doing ahead of time compilation. We talked about that already. IBM Samaru, mentioned that. Community and certified, they have OpenJ9, so they have their own JVM. And it's interesting because IBM created the JVM from scratch. It's not OpenJDK. It is compatible, so you can run your code on Samaru, it will work. And like I said, the certified edition passes the TCK so that you can be sure that it works. For the community edition, yeah, they don't pay the fee for the TCK. And that's the reason. It has faster startup, lower memory consumption. So if this is for you important that you have a little bit faster startup or you have a lower memory footprint, then this one is for you. And they have also an AOT compiler. And the interesting part is they said it creates dynamically compiled AOT code. I was not really sure what that means, but I guess at startup, they load stuff. When they figure out it's compiled, they just compile it to native code and use it the next time at startup. That's what I think, which leads to faster startup. And they have instant on. Who heard about Crack? Nobody? Yes, come on. I talked about that last year, every time, even here. So Crack is cool, and they have the same. It's called instant on. So it's to checkpoint and restore your JVM to get really fast startup times, but you keep the JVM, right? So they use Creo as we do. And what it is, you can think about it like if you close the lid of your laptop and you reopen it the next morning, it's there, right, with all the applications that have been open. And we do the same with crack on the JVM. So you can stop your application, like shutting the lid, and then restart it. And restarting means it loads the stuff just from the disk back into memory. And we can do that within 50 to 100 milliseconds. So we get the same startup time that you get with a native image, but it's the complete optimized JVM, depending on when you create the snapshot. And this is the same. It's called Instant On the IBM Samaru JDK. They have a JIT server. That means you can run one instance of Samaru on a server. And then you can, if you have services, they send the code to the compiler of that server. It compiles the code. The next time you ask for the same code, you directly get back the compiled code. So you don't have to go to the interpretation C1, C2 compilation. Okay, then we have our own one, which is called Azul Zulu. And first of all, it's free for use. People always think you have to pay for it. Now you don't have to. It's free. You can pay for it. If you need support, you pay for it. If you don't need support, you just use it for free. It's fine. So we have inbuilt Azul vulnerability detection. That means our JVM, instead of having a scanner that scans for CVEs in your code, the JVM loads all the classes anyway. So the JVM knows exactly what was loaded. And so we check with the so-called forwarder that then hooks up to the internet. We check with the database if you use vulnerable code. And we can tell you even if you have a dependency on Log4j, on a vulnerable version of Log4j, we can tell you if you use it or not, because we know if the JVM loads it or not. Right? So that's the difference. And we have crack. I already explained that, and crack will be available this month. I think in 2 weeks we will come out with the official version of Zulu that supports crack. Then we have Platform Prime. I already mentioned that. So this has a lot of features, like we have our own JIT compiler, which is based on LLVM. We have our own garbage collector. I already mentioned that. We have Ready Now, the stuff that was copied by Dragonwell, the J warm-up thing. But this one passes the TCK. We also have a cloud-native compiler, which is in principle the same that Samaru offers with this web compiler. So we can run a cluster of compilers in the cloud. And then we compile code. Every time a service sends the code, the cloud compiler compiles it and keeps it. The next time the service asks for the same code, it directly gets the highly optimized version. So it means if you scale out fast, you just the first time you need a little bit longer, and after that it's faster. And also this one comes with the Azul vulnerability detection inbuilt and crack. But this one will be probably mid of this year, so it's not inbuilt yet. So you see it's a lot of stuff there in Prime. And you can try it for free if you like. So it's free for testing and evaluation. Right. Takeaway, and I'm on time, that's cool. Are all those builds of OpenJDK really different? Technically, no. It's all the same, more or less. It's the same source code, right? So some have different features. We saw that. That can be beneficial in some parts. For example, Corrado with Snapstart and Firecracker, it's great for Lambdas. It doesn't really help you if you run something else. If you run Corrado on some other cloud, it doesn't really help you there. Service support and cost, of course. There are differences, and that's where you really see the difference between the JDKs. It's more the vendors and what they offer to you. But in the end, so choose wisely when you choose a JDK. And that's it. Thanks for attending. I hope it was helpful.